So I'm just going to hand over to Shai, who's going to walk us through how to deploy AppSec for Kubernetes Ingress controller.
Thank you, everyone. And I see that also Roy joined us. Roy is managing the groups that are developing this product. So feel free to ask any questions on the Q&A. And give me a moment. Yeah. So let's start. So let's start from the very beginning. I will start with a very common basic architecture, Kubernetes cluster with the public internet access. The Kubernetes can be managed. It can be on Azure AKS, AWS EKS, or other platform. The Kubernetes can also be an unmanaged deployment on the cloud or on-prem. And what is common to most of the organization that all wants to publish the application to the internet and make sure the application are protected. Now, on that Kubernetes cluster, we are going to run two applications. There can be many microservices pods that serve each application, but we want to focus today on the pods that we want to expose to the internet, the front-end pods. The use case here is a company in the food industry, and they currently have two online shops. In one of them you can order juices, and in the other one you can order sushi. And I decided to separate the application into two namespaces. One is a sushi shop, and the other one is the juice shop. Now, in order to access an application, you will need to create a service to each application and associate it with the application. Let's take a look on what we have currently right now on the application and deploy those services in application. So let me share the screen and let's see what is going on over here. So you will see that I have the namespaces. Okay, I've prepared the namespaces for the juice shop and also for the sushi shop. And let's bring the pods. So the pods that is currently running is only the sushi shop. So let's expose it. I will show you that I don't have a service right now. Okay, those are the default services that coming with the Kubernetes. So I will now expose the service of the sushi shop. Before we do that, let's take a look on this service. So I prepare a YAML file with the service. So let's take a look on it. And this is the YAML file. The type is a service, and the type of the service is cluster IP. So basically, when you expose a service, you can this type can get three parameters. It can be cluster IP, it can be a load balancer, it can be a node port. So cluster IP, when you publish a service with cluster IP, it only expose the application to internally in the cluster. If you want to expose it outside of the cluster, you have two options. One is node port that is going to expose the application on the interface. If we are talking about AWS, it's going to be exposed on the ENI IP of the Kubernetes nodes. And if you will write here, you will write a load balancer, is going to expose it with a load balancer. So the service will create a load balancer. The default one is classic load balancer. You can change it with annotation. I will show you it later on. And in this case, as we want to expose it only internally, we don't want to expose it without a protection to the world, we are going to expose it with a cluster IP. And you can see that the service is going to listen on port 80, and the target port, the container or the pod itself, is listening on port 80. So it's going to get the traffic on port 80 and forward it to the pod on port 80. So let's run the first service. And now let's also take a look on the juice shop. The juice shop pods are not deployed yet, so let's cut the YAML file for the juice shop. And you'll see that this is the kind is deployment. The name is juice shop, juice2 shop, and the namespace is juice shop. I will run 3 replicas of the application. And you can see that the container is listening on port 3000. So now I will want to deploy the application. So the application is deployed, and I have also a service for this application. It looks the same, also a cluster IP. It looks the same like the sushi service. I will run the service that will expose the application. So now we can take a look again. And we will see that the 2 services were added. This is the sushi shop. This is the namespace sushi shop, but this is the service name. And we have also an additional one for the juice shop, the juice SRV. Okay, and the type again is cluster IP. And let's take a look also on the pods. You will see the pods. We'll see 3 replicas of the juice shop. Okay, and we have just 1 replica of the shop. Let's switch back to the presentation. So now we have the service and we have the application, and we are ready to move on to the next step. And the next step would be to deploy the AppSec Ingress controller. The AppSec will receive the requests that are coming from the internet, inspect the traffic, enforce the policy, and in case it does not block it, is going to route the traffic to the right destination based on the host header URL. Okay, so if the user requests the application, the sushi shop, sushi.mydomain.com, will get to this service and the application, and if he requests the other one, the juice shop, he will get to this container. Now, as you already know, you will need also a service in order to allow access to the AppSec Ingress controller from the internet, and this is the service. This time the service type is not going to be cluster IP, but it's going to be a load balancer. When a service is being created with a load balancer type, it automatically creates a load balancer. And this is the load balancer that is being created. It will also create a target group of the cluster node, the EKS cluster node in our case, and it would also create a listener automatically on TCP port 80 and port 443 and forward the rule to the target group on the service auto-generated port number. So once the service is being created, it generates automatically a port, and the load balancer will be configured to send the traffic automatically to the service port that is being generated automatically. And you will not need to deploy each one of the AppSec controller components one by one by running the YAML file. We are going to provide you a Helm chart that will deploy and configure the elements automatically, and I will show it in a few moments. And to get the Helm chart and configure this part, we will need to switch to the Infinity portal. Infinity portal is a Checkpoint SaaS platform, and from the Infinity portal you will manage all the aspects of the AppSec, the setting, the policy, and the monitoring. So let's switch to the Infinity portal. So this is the Infinity portal. You can reach this portal from portal.checkpoint.com, and if you don't have a user, you didn't register yet, this is the time to register, and you can try out the products for free. So in the Infinity portal, basically you will find all the SaaS application that Checkpoint provide, and we are talking today about the application security. You will find it under the CloudGuard section, application security. Roy, can you put yourself on mute? So once you hit the portal, you will see that you have an option to run a wizard that will help you to configure all the settings that you need in order to protect your app. But I'm not going to do it from the wizard, because I want you to get a better understanding about how it works, and it might help you on your own deployment. So you will see how do I do all the connection by myself. So basically for deployment, we need to use two parts. The first part is the assets, and the second part is the profile. So for that, I want to switch to the presentation again, and I want to explain you what are assets and what are profile. So basically, asset represent the application you will want to protect. In our case, we have two applications, and each asset will get a different policy setting. So for example, the Sushi app, I can set the threat prevention mode to prevent, okay? And the Juice app, this is a new, let's say that this is a new application that the machine learning engine, we just launched it, it still learn the traffic. So we'll want to set the threat prevention mode of this application, of this asset, to learn and detect. And once the ML engine will finish the learning process, I will switch the mode to prevent. There are also other settings that you can set on each asset, like exceptions and more settings, but I choose those ones because those are easy to understand. So you understand what is asset now. So what are profiles? So profiles are unique setting for the nano agents that will be aligned with the platform or infrastructure on which you will deploy your agent. So once you create a new profile, you will be asked to choose on which platform you are going to deploy it. If it's going to be a Docker profile, Kubernetes, or AppSec gateway profile. And if, for example, you select the AppSec gateway profile, you will also need to select the environment. So if it's AWS, Azure, and so on. And the reason that we are doing it, because based on the profile, on the environment the agent is being deployed, is getting a unique settings for each environment. So in our case, we choose the Kubernetes profile, and we build a profile. And for each profile that you will create, the profile will generate a token. And when you deploy an AppSec agent, you will deploy it with the token that you will get from the profile. So it can be a CloudFormation template, or it can be any other template, YAML template. Anyway, you are going to deploy it with the token that you got from the profile. And once the nano agent will communicate with the Infinity Portal API, he will register himself and will associate it with the relevant profile. And the last setting that we will need to do is basically associate the asset with the profile. So the agent will get the protection setting for the two assets. just to make sure that we are on the same page and to get a more deeper or clear about understanding about the profile. So let's say that this application, the Sushi CP AppSec site, this is the application that they want to load, share the traffic between two data centers. One you will deploy on EKS on let's say AWS US East 1, and the other one you are going to deploy on Azure AKS on Europe. So for that you will create another profile and deploy and associate the asset with the profile and deploy the agents on the AKS cluster, and those agents are going to be deployed with the token ID of the new profile and register to the Azure profile and get all the settings. Okay, so this is how profile works. So let's move forward. So now that you understand this structure, let's see how to configure it step by step on the portal itself, on the Infinity portal. So let's do that. Okay, so in the Infinity portal, so instead of doing the wizard, I'm going first to the profile, and in the profiles, I will create a new Kubernetes profile. And let's give the profile a name as we install it on AWS East 1. As you can see, it's generate automatically a token, and this is the maximum number of agents that can be registered in parallel to the profile. Okay, and the default setting is application security. We have another feature which is called product access control, but we are not talking about this feature today. We're talking about application security. And as you can see, it gives you the command. From here, you will just need to copy it and run it over here to get the Helm chart. Okay, so we have the Helm chart, and I will publish the settings. And I have here another command. This is a command that will run the Helm chart with the tokens. Okay, we take the token parameter and it will run the command. So let me just copy it here and let's run it. So now I'm going to install the controller. This is what installing the controller. Okay, and the controller has been installed. What is the controller? Controller is basically a pod, and it can be a scale set. You can scale it, and it can be scaled automatically up and down. So let's take a look on the controller. You will see it. So this is the controller, and if I will take a look on the Ingress on the service, get the SVC. And it's going to be installed to the default namespace, so I don't need the capital A. So we'll see also the service. So it's this one. This is the service, and you see the type is load balancer. So he deployed a load balancer, and this is the external IP of the load balancer. Okay, so once you are going to create a CNAME for your website, you are going to point on this URL. We'll do it in a few moments. As you can see, the agent already, this is a pop-up that I see here on the Infinity portal. So the agent already successfully connected. I will switch back again to the profile. You'll see that they have one connected agent. It's happened almost on no time. And you will be able also to see the connected agents. You will see them over here. And the agent, basically this IP, it's as by default, once pods are going to the internet, they are hiding behind the ENI of the Kubernetes, one of the nodes, depending on which nodes they are deployed. But basically, they are hiding behind the node IP, the ENI of the node. So with the profile, we are ready to go and create the assets. And we are going to create two assets, as we have two applications. One is the sushi and the other one is the juice. So let's create the asset, and I'm creating a type web application. Okay, it's a user interface for users that will want to access my application and order sushi or juice. So the first one is going to be the sushi shop, and the URL of the sushi shop is this one: https sushi.cpappsec.site. I will edit. I will click next, and I'm starting in learn and detect mode because the engine needs time to learn the application. And here he asked me how does the machine learning engine is going to distinguish between the user. Is it going to be based on XFF, X forward 4? This is a header that is being added to each HTTP request, or based on IP. So here, for these questions, you need to understand, and it's depend on the load balancer and the platform. So if we are talking about as I told you, let's take a look on the Amazon, and as you can see, this is the load balancer that has been deployed with the controller, and the default is classic. By the way, classic is going to be deprecated soon, so you not to be able to use it. But classic and application load balancer, AWS classic and application load balancer, does not going to preserve the source IP address of the client. Okay, so if you are using with the application load balancer, you will need to use XFF. As we are going to change it right now, we are going to change it to a network load balancer. We are going to do it in a few moments. We are going to see the source IP. We are going to see the source IP of the client. So the setting that we will do over here is source IP. Okay, and here also you can add IPs that you trust that will try out the application, and the machine learning will be able to learn how legit users are behaving, and the engine will learn faster. Next, on this stage, you can create a profile, or you can associate it with existing profile. As we created the profile together just a minute ago, I'm going to associate with existing profile, and the profile is this one. This is what we have created, Kubernetes AWS US East 1. Click next, next, and I have my first application. I'm going to do the same process for the second application. And the second application is a juice shop, and I'm going to run through it fast. Let's do it. So this is the juice. Next, learn source IP, associate with the same profile. Click next, and done. And basically this is it. We are done with this part. And I will click enforce policy, and you will see a moment over here. You will see a pop-up that say that a new policy was published or enforced. Let's wait for it. By the way, if you want to see the version that the currently the agent has is 119. If you will go to the profile and go to advanced, you will see that it's 120. So we are waiting for the agent to get 120. So it's still 119. It's going to take like a minute or so. So the next time the agent is going to query the with the API is going to query for a new policy, is going to get a new policy. It's going to take like a minute or so. So let's see what left. So all of this infrastructure is and those components has been already deployed, and so all the element is placed. So let's say that we have created a CNAME record on the DNS zone for my DNS on my DNS zone for a CP AppSec site, one for sushi and the other one is for juice, and we point it. The CNAME record is pointing on the URL that of the load balancer. This is a URL that AWS generated. By the way, it's the same for Azure as well. And by the way, for AKS, if you deploy a load balancer, the load balancer does not preserve source IP, so you need to set it to use XFF. Now, if a user open a browser and he put the address of the sushi shop, okay, sushi.cpappsec.site on HTTPS is going to hit the load balancer. The load balancer is going to send the traffic to the AppSec service, and the AppSec service is going to redirect the traffic to the AppSec Ingress controller. The Ingress controller will check the traffic. He see if it's legit traffic, and if it's legit traffic, he need to decide where, based on the source IP, if it's the sushi, you need to send it. But how does the AppSec Ingress controller will know where to send the traffic, if it's need to send it to the sushi service or to the juice service? So for that, there is another Kubernetes configuration file that is called Ingress. On the Ingress, you will write routing rules. For example, if the host header you get is sushi, then send it to a sushi SRV on port 80. Remember, this one is listening on port 80. And if the request, okay, so if it's a sushi, send it to the sushi. If it's I replace it, it's sushi, and this is the juice. So if it's a juice, send it to the juice. Okay, so what we will need to do now is basically configure the Ingress, and you have a few ways to configure it, but as I deploy it on two different namespaces, I have created two YAML files, so two Ingress file, one for the juice shop namespace and another one for the sushi shop. And what I'm going to do, I'm going also to terminate the TLS connection as it's HTTPS. I'm going to terminate the connection on the controller itself. And you have few options, so you don't have to do it on the controller. You can also terminate on the NLB. If it's AWS, you can create a listener type TLS, and AWS give you the options to upload more than one certificate, so you can upload. I don't think it's limited, but on the same listener you can upload many certificates, and based on the SNI that is coming from the user on the user request, he will know to serve the right certificate. And there is it's a different configuration that what I'm going to show you now to terminate it on the load balancer. There are pros and cons to each configuration, and the same also for ALB. And for ALB, you will need to deploy another Ingress load balancer, AWS Ingress load balancer controller. it's more complicated configuration. And if you need this configuration, just drop me an email. I will share my email later on, and I will be happy to assist you with that as well. So we are talking about the basic configuration, and now I'm going to configure the Ingress and terminate the connection on the Ingress controller. And I'm going to first, what I'm going to do, I will going to create a self-signed certificate. This is just for my demo environment, so I'm going to create a self-signed certificate for the sushi and also for the juice shop. Okay, so let's start with creating the self-signed certificate, and let's do that. Okay, so OpenSSL, I use OpenSSL to generate a self-signed certificate, and this is for the sushi with this URL, sushi cp AppSec. Okay, so it's going to generate two files, the sushi TLS key and also the certificate. So I will do that, ignore the error, he created the two files, and I will do the same also for the juice. Okay, and this is for the juice. He created the two files. Now I need in Kubernetes there is a component, or I don't know if it's a component, but with a kubectl get secrets, you will see all the secret, and secret is associated with the key and certificate. So I'm going to create two secrets, one for the juice, and this is how you create it. kubectl create secret TLS, sushi secret. This is the name of the secrets, and the sushi secrets is as those the key and the TLS that I've created. Okay, and this is for the sushi. The next one that I'm going to create is for the juice secret. It's the same command, but with the other files. Okay, so we have two keys. And now what I want to show you is the Ingress configuration. So let's take a look on the Ingress configuration of the sushi Ingress TLS YAML. I have prepared it in advance. It's very easy to understand the YAML file. So you see that the kind is Ingress. You see the namespace, sushi shop. So I have two ingresses, one for the sushi, the other one is for the juice shop. And you see the spec. The spec is TLS, and this is the host of the TLS. And the secret name, as you can see here, it's the same secret. Okay, this is for the sushi. This is the certificate that he's going to use, and the private key. And he's saying if the request is to sushi cp_appsec.site, send it to the service, sushi service. Remember, on top of the pod, we have a service that's listening on port 80. Okay, so I'm going to apply the ingress. So we have one ingress created, and I'm applying also the second ingress. Okay, for the juice shop. So basically now, I've published the two applications through the AppSec. So as I don't have a redirection, I didn't create a CNAME. I will use curl. So let's check what is the kubectl get svc. So this is the URL that I need to go to. Let's see if I can get to this URL. So we run a curl command. So this is the curl command, and since I don't have a host on the DNS for sushi, this is like changing the host file on the Windows machine. And -k, he doesn't going to show me a message that the certificate, he doesn't trust the root certificate. Okay, so this is why I use -k. So let's say if I get answer, and wonderful, I get the website. As you can see, this is the sushi This is images from I'm getting from the sushi restaurant. Now, let's see if I'm getting the juice shop. And give me a second. I will edit my file here. Yeah, so I'm ready. So now I'm going to the juice. Okay. Let's see if I get it. I also get it. This is my juice shop. You can see this is the juice shop application. So wonderful. I have been access to both application. And now what I want to see, let's see if we'll run just a test to see if my AppSec prevent some traffic. So for that, let me ping to the URL, and I will put it on my host file, and we'll open a browser. Okay, so this is the URL of the load balancer, and on the host file, I will change the IP. Wonderful. And I will take this URL and try to access it over port HTTPS. So HTTPS, it doesn't trust the certificate, of course, because it's self-signed certificate. And let's try to log in. Put this email. It's like a simple SQL injection, and it's it's not on prevent mode. This is why I get the site. Let's see what we see on the Infinity portal. So if I will go to monitor, you will see the request that was logged, and you'll see an SQL injection to the juice shop. This is the request that I've just created. Simple as that. So basically, this is it. You see how much time it took me to publish the application, create all the services, deploy the AppSec. It's super easy, less than a few minutes. And by the way, all the AppSec, and Rui, you can maybe elaborate more about that. How does this is integrated with the CI/CD pipeline? So basically, DevOps will be able also to configure everything on the AppSec side from the pipeline. And if you have any questions, I will be happy to answer.
Thanks so much, Shai.
Do we have
any? Have a few questions. Yeah, we have a few questions that came in during that deep dive, and it was amazing to see how you set everything up and had it running, actively preventing in less than half an hour. So that's really cool. So there was a question about reposting the link for the free trial for AppSec and the lifetime protection against Log4j. You can scan that QR code, and that should give you the access. We had a couple of questions about whether this would work on on-prem deployments if it's only for cloud-native applications. And the answer to that is yes, this also works for on-prem applications as well. We had a question about support for AWS and Azure. So yes, this will work for applications that are hosted on AWS and or Azure. And then the last question is about what are additional deployment options, and we're kind of running over time. So Roy, if I could ask you to elaborate a bit more on the
deployment. So I can answer quickly. We can integrate with every machine that has Nginx in it. So you can just install our agent and get the traffic inspected. We have a deployment model of Dockers. We have some customers that use Nomad to manage Docker. So it's a very nice solution that we have. You can just, again, install 2 containers and you have AppSec up and running. We have Kubernetes and we have scale sets and VMs. Shai showed Kubernetes. It was actually an excellent demo. And we are building more and more options. So supporting more and more versions, integrating with more and more products. This is something that we keep on improving on our side. Just want to have like the last seconds to talk about what Shai said about CI/CD and the idea to shift left configuration. So in a few weeks from now, we are about to release Terraform support. So you will be able to do all the configuration that Shai did using Terraform code, and also we have our official API. So anything that Shai did in the UI, you can do using APIs, and it's already supported.
Perfect. So thank you so much, everybody, for joining us today. If you'd like to forward the link to this talk to any of your colleagues, this will be available.
I think, Yafa, the QR, they're saying that the QR takes to a QR generating site. Maybe we can just share the link.
Yep, so you should be able to see an announcement for all of those of you who are viewing the webinar. There should be an announcement now on the screen with the link to that landing page where you can get your free trial. So apologies for the technical issue with the QR code. So if you'd like to share this link with any of your colleagues who would like to watch this on catch up later, you can. It will be on Bright Talk. So thank you again, Shai and Sergio and Roy.
Yafa, one last word. It's going to be also published on Checkmates, on Cloudmates, the video and also the deck and all the YAML files that I use with a step-by-step instruction. I will make sure to upload it to Cloudmates by the end of the week. So drop by and yeah, and if you need assistance, Yafa, can you share also my email if you need assistance on deploying this solution? You need a specific setup that you need, I don't know, application load balancer, Azure application gateway or something like that, just drop me an email.
Yeah, so I've popped Shai's email and Sergio's email up here on the slide. So please note those down and reach out with any additional questions that you might have.
Yeah, thank you. Thank you very much, everybody.
Thank you.